Well, good morning. We're going to go ahead and look at some graphing of inequalities, especially absolute value inequalities, and how to solve them using graphing. First, I want to quickly review some things you should have picked up on graphing inequalities. An inequality with one variable, your solution can be graphed on a number line. So let's go ahead, and I've got a few things printed out here. I'm not going to take the time to read them all to you, but we're going to work through these examples together and kind of touch on some of those facts. So you just basically make a number line, and then we're going to say, okay, if I have a value of +1, and then there's a 0, -1, -2. I don't get really picky on what this graph looks like. I usually like you to put the 0 and then the 2 endpoints. Now, if it does not have an equal to, you can see that these two things here, neither one of them have an equal to bar. So what they're going to be is actually open circles. So I'm going to have an open circle. I'll go ahead and use the same yellow color, I guess, on the -1. On the +1, and an open circle on the -2. The other thing that's handy about inequalities is I shade in the same direction as I'm pointing. So since this one is pointing to the left, I'm going to shade to the left. Since this one's pointing to the right, I'll shade to the right. And anytime you see two separate pieces, that's going to be that or there. So that or generally in an equation would be two separate pieces for your inequality. Now, when I go ahead and try the next one, let me get back to go ahead and do this one above so they don't all run together. And once again, I'm not too picky, but give me a 4, there's a 5, there's a 6. That gives you an idea of where the number line would be. Once again, these do not have equal symbols, so I'm going to need open circles. I'm going to use that yellowish color again. So an open circle on the 4, since there was no equal on the 4, an open circle on the 6. Now, one thing I want to point out is this one here, is that if I have the x in the middle, I can literally think of it as the x being between 4 and 6. So I'm going to shade the values between 4 and 6. So anytime you just have one equation without an or like that, that's going to piece it together as just one piece of the graph. Now on this one with an and, one thing I want to point out on the and is I could actually rewrite this equation if I wanted to. Instead of thinking of this equation as x is greater than 1 and x is less than 4, it's almost like saying, well, I've got a preschool group that is only going to take people who are older than 1 and people who are younger than 4. Well, most of you can figure out, well, if you're younger than 4, you could be 0, 1, 2, or 3, but you have to also be older than 1. So that's got me down to just the 2s and the 3s. But technically, with this situation, as long as you had turned 1, if you were like 1 in 1 month, you'd be fine, or 1.5 years old, you'd be fine. But as soon as you have that 4th birthday, you could not be in this preschool class. So without the equal to's, once again, this is going to give you, actually, let's think about this one. Let's imagine that there were some equal to's there, and I will probably go back and edit these original notes in a minute. Let's say they did have equal to's. What that's going to mean is I'm going to have a closed circle. So anytime I have an equal to, that'll be a closed circle on the 4, a closed circle on the 1. And since I have to be bigger than 1 and smaller than 4, it's going to be this part here, because ands tend to go together. You're like, well, Mr. Hass, it looks so much different than the last equation. It does, but the truth is I could have rewritten this equation just putting the x between the 1 and the 4, because that means people less than or equal to 1 years old and less. If 1 is smaller than x and x is smaller than 4, that's going to be the part in the middle like that. So that's what you're going to have. One more that looks a little weird, but it's actually the easiest one of all, is a not equal to. There's only one point there, so usually I'll just mark the 3, and to give myself a second point, I might go over and mark a 0. And if it doesn't have an equal to, so it's definitely an open circle. And since it's not equal to 3, anything that's not equal to 3 is going to be part of my solution. So I'm going to have everything over here that's bigger than 3, everything over there that's smaller than 3. So basically it's the entire graph except that number 3. So that hopefully will give you an idea on how to graph these inequalities. If you've got any questions, feel free to reach out during our Zoom session.